Alright. iPad ran out of memory, so I had to delete some stuff here. So right here, h we said was a half. So in our formula, 1/2 over 3 was 1/6. And now you're just going to go along and put these numbers in. So I'm going to have 0 plus, and then you're just going to alternate 4s and 2s in front of these numbers. So it's going to be 4 times 5/16 plus 2 times 5 plus 4 times 405/16 plus the last one you don't put a 4 or 2, right? Notice here it goes 4, 2, 4, 2, 4, and then the last one is just whatever it is, plus e. Kind of weird. Don't worry about why. That's all you gotta do. Plug that into your calculator, and you should get 385/12 is your answer. So that's just another way of doing a Riemann sum. You'll have to do a few of those on your homework. Just basically using a formula. Plug and chug. Easy deal. Alright. So the other thing I think we talked about it. I don't remember if we did any homework problems on it. Was finding the average value of a function. Well, I know we talked about it, because I remember doing that. Remember the average value of a function. Formula was 1 over b minus a, and the integral from a to b of f of x dx. You needed that on one of the bonus on your test. Just to do an example. Let's say we had, we'll just use that same last problem. Let's say the problem said to find the average value of and the average value of that function from, we'll just go 0 to 2 again. Well, to do that, just use this integral. It's the only part you really have to remember is just remember to do the integral and then the 1 over b minus a. So if I set up the integral first, it's going to be from 0 to 2 of 5x to the 4th dx. Then out front I need 1 over 2 minus 0. So basically it's going to be 1/2 times whatever the value of that integral is, which you should know how to do. Hopefully you all did it right on your test. So remember, take the antiderivative of that, which is just x to the 5th. Alright? Because the derivative of that would be 5x to the 4th. So from 2 to 0. So I'm just going to leave this 1/2 sitting out here. Plug that in, 2 to the 5th. Let's see what's that. 2 times 2 is 4, 8, 16, 32. Well, it's 2 to the 5th minus 0 to the 5th. What did I just say? That was 32. 32 minus 0, 0, 32. Half 32, 16. So the average value of that function from 0 to 2 is 16. Easy deal, right? Good. There's one of those on your homework. Now let's move on to chapter 7. We're actually going to skip 7.1. Not completely, just for a while. I don't know why it's thrown in at the beginning of this chapter, because it has nothing to do with the rest of the chapter. It's called slope fields. We'll do it later. I don't know when we'll do it. I'll throw it in at some point, but I just don't think right now is the time. So we're going to move on to 7.2. And this is going to answer one of the questions you guys had earlier. when we were doing integrals before, like this one, that's called the definite integral. Well, now we're going to do indefinite integrals. Remember to write big. And you basically already know how to do this. Indefinite integrals are basically just antiderivatives. And it's just a notation for antiderivatives. Like, let's say we have a function, let's say we have f of x equals x squared. Well, the notation, if I want the derivative of that, we could write it as f prime of x, it would be 2x. You could write it as d dx is 2x, right? Means the same thing. But if we want to go backwards to find the antiderivative, the way you write it is an indefinite integral. So it's just the integral sign. That was an ugly one. That's horrible. Integral sign with no numbers. So here I would write the integral of f of x dx equals, and if I'm doing that one, 1/3 x to the third plus c. In this case, when you do indefinite, you do need the plus c. So, yeah. Right, definite. Think about definite integrals. Means definite mean like defined. So you have a defined section that you're looking at. Indefinite basically just means antiderivative. So we're not going to use that word much anymore, antiderivative. Probably say integral. For indefinite integral or just integral, which means don't do the derivative, go backwards, do the antiderivative. So, all these words. So, do another example here. I'm just going to do a few examples out of the book. We'll be done. How are we doing? This, all right. So, if we want to find indefinite integral of x squared minus the sine of x dx. Like I said, basically it just means antiderivative. So to do that, antiderivative of x squared, that's the same one we just did, so that'd be 1/3 x to the third. Antiderivative of sine of x, let's see. Derivative of cosine is negative sine, perfect. Plus cos of x, right? Derivative of that's negative sine of x, derivative of that's x squared. Add the plus c, and we are done. If you're ever unsure, just go ahead and take the derivative of what you wrote down, and you should get back to that. Derivative of that, bring the 3 down, 3 times a third is 1. X squared, derivative of cosine is negative sine. Derivative of a constant is nothing. It worked. That's it. That's all indefinite integral is. But of course, whenever something seems so easy and like it's just going to be money and you're going to ace the test, it gets harder. And this does get really hard and really confusing really fast. So, I'm imagining this is going to take a while to click. Not this, but watch. Of course, chain rule, product rule, all that stuff's going to come into play. This was a very simple case where it was one piece plus or minus another piece. It's going to get harder, of course. Oh yeah, I forgot. If you look on page 337 in your book, there's a nice chart there that shows you a bunch of indefinite integrals. You basically know them all. But they might be in those flashcards I passed out to you earlier in the year. I don't know, I left them at school, so I don't know if they're in there. But things like things in the chart, things like the indefinite integral of secant squared of u du. Well, you should be able to think backwards in your head and know that that's the tangent of u, right? Because the derivative of tangent is secant squared, so the integral of secant squared is tangent. And, plus c. And if you're looking at that chart on page 337, it's a good chart. You'll notice they have u's and not x's, which I think is important. And I think we should have done that when we learned our derivatives, because then you would all be way less confused on this whole chain rule business. For example, I notice when a lot of you do, like, say you want to do the derivative of inverse tangent, and there's something inside here like x squared. Oh no, let's change that. Let's say you wanted to do, here's inverse tangent of, let's make it 3x. If I wanted to do the derivative of that, a lot of you want to write 1 over 1 plus x squared. Well, that's wrong. It's 1 over 1 plus whatever's inside of here squared. So it should be 3x all squared, or 1 over, well, and then times the derivative of the inside. So we always forget that part. You screw that up. That's the reason these u's are here. And it was something I kind of showed you guys earlier in the year when doing derivatives, to use the u called u substitution. And when I showed it to you, no one liked it. Well, I guess we really didn't get into it too hard, but you guys immediately just went, no, that's too hard, don't do that. But now we're going to have to, because, well, it'll make your life easier. So here, I'll kind of review u substitution first before I get back to the integrals. So I'm just going to review using derivatives, since it's something hopefully you got down pretty well. So here we go, u substitution. Let's say we have a function. Something you know how to do, x squared plus 3 to the 4th. If I want to find the derivative of that, I'll do it both ways. I'll do it the way we've been doing it, just chain ruling it, and then I'm going to show you how to do it with u substitution. And you'll see it's the exact same thing in the end, just a little different process, a little different way of thinking. So the way we do this, we would drop the 4. Derivative of the outside, we drop the 4. I guess I should write that. Drop the 4, leave this crap on the inside. Subtract 1 from the power, there's the derivative of the outside, times the derivative of the inside. So the derivative of the inside is, let's see, derivative of that's 2x. That's it, right? 2x times 4, so I'd have 8x times x squared plus 3 is the third. And I'd be done and happy. That's the way we've been doing it. Well, use substitution, similar thing. So, same function, we'll do it a different way. Here, the trickiest part about use substitution is picking what you're going to let u equal. U is just a variable, it's just a random letter. You could use any letter you want. It's just always, even when I was in college, they called it u substitution. They just use u. I don't know why. So in this one, it's easiest to let u equal all this stuff inside. And we'll work more later on how to choose what u is. In today's homework, kind of easing you into this, they're going to tell you what u equals. They're going to say, here, do this one, here's what u should equal. And this one will let u equal x squared plus 3. And then whenever we do this, we not only need u, but we also need to know the derivative of u. So if I do the derivative of this, that means du will equal, derivative of this side is 2x, derivative of 3 is nothing. But remember, this is like implicit differentiation. There's a good word for it. Remember that? That's where you have more than one variable. So derivative of u is du. If I do the derivative of this side, it's 2x dx. So I'm going to use both of these things and substitute them in here. It's a magical thing will happen here. So if I do that, plugging instead of x squared plus 3, I'm going to substitute in u. So I'll have u to the 4th. This is the same as u to the 4th. So fu, you get to say fu too, that's kind of funny, will equal u to the 4th. Now I'm going to take the derivative of this, right? So f prime of u will equal, well, derivative of u to the 4th is just 4u to the 3rd. 4u, oh, I'm not done though. It's 4u to the 3rd du, right? If I do the derivative. That's all I've done. Just to recap, I let u equal this, and so I rewrote this using u. So it's just u to the 4th, took the derivative, it's 4u to the 3rd du. Now all I do is take this stuff and plug it back in, to get rid of the u's and switch it back to x. And if I do that, if I switch it back to x, you will see well now u is x squared plus 3, right? X squared plus 3. And so I need that to the 3rd power times du. Well, du equals this. So I'll substitute that in, 2x dx. Hey, does this look familiar? Oh, I should have, yeah, I just realized a mistake earlier. 2x times 4, 8x times x squared plus 3 to the 3rd dx. Hey, that looks familiar. It's the same thing as here, except here I forgot my dx. That's what I was talking about. That's it. That's u substitution. Pretty easy. Gets harder though. I guess it's a way of seeing the chain rule a lot easier, knowing what to do there. So now we're going to do some indefinite integrals with u substitution. I'm going to do it on camera at the time. Alright, so let's see. Okay. I guess before I do that, I just want to do one of these examples here. Okay. I'm going to change up my order of things I was going to do here. I'll do one of them. Let's do a u substitution problem. So let's say we want to find the integral of x squared times the square root of 5 plus 2x to the 3rd dx. Told you it got harder. Hardest part is figuring out what u should equal. This one's not bad. You might think u equals x squared might work, or you might think u equals that might work. Again, we'll talk about how to decide that more later. Let's just get used to doing the process. On this one, we're going to let u equal 5 plus 2x to the 3rd. And again, what do we do after that? If I know what u is, I also need to know what du is. So derivative of that, derivative of both sides, du will equal, derivative of 5 is nothing, derivative of 2x to the 3rd is, drop 3, 6x squared dx. So I know u and I know du. So now I plug them in, integrate, and then plug them out, I guess you call it. Sorry, I'm shaking the camera here. So plug this crap in. So I'm going to just rewrite this integral here. Oh, and this one's a little different. This is actually a little harder. What I got to do here, I guess I'll plug in u first. So if I'm going to do this, I'm going to go integral of This could be hard to see sometimes. Okay, first, I'm having trouble coming up with the right words here. See, I can't just plug in u for this, or u here, because here's what happens. If I just plugged in u, I'd have x squared square root of u dx. Right? I plugged in u for that, I substituted it in, but I still have this x squared and dx. I can't have that in there. I need it to be all in terms of u. But I've got this second piece right here. So I need to use this also. Notice I have a dx here and a 6. I have an x squared. That's nice. But I got that 6 there. Well, over here I've got x squared and I've got a dx. I want to get rid of this x squared and dx and change it into du. And the way I'm going to do that, think about how can I make this look like x squared dx. So, like I said, struggling with words here. Maybe I'll just do it and hopefully you'll see it. Instead of x squared dx, I'm going to take it. If I multiply this by 1/6, it's the same as that. So basically what I'm going to have is 1/6 the square root of u du. Hopefully you can see that. Because if I take 1/6 of everything here, 1/6 du, it's the same as 1/6 of this side would just be x squared dx, right? That's what I wanted, so I plugged in 1/6 and du. I guess there's a decent way of explaining it. So now I've got this, and that's what I'm going to integrate. So I'm going to rewrite it as 1/6 u to the 1/2 power du. Integrate that, or antiderivative, remember, the integral, indefinite integral, same as antiderivative. If I have a u to the 1/2, doing the antiderivative or integral, my u would be to the 3/2 power, right? Because if I subtract 1, I'll get down to that. So now 3/2 times what gives me 1/6. And if you struggle with fractions, as I know a few of you do, I'll not mention any names since we're on YouTube. 3/2, I'm just going to do a little side problem here. 3/2 times what gives me 1/6. I'll just divide by 3/2. 1/6 divided by 3/2, that's the same as 1/6 times 2/3. And be 2/18 or 1/9. So this is 1/9 u to the 3/2. If I do the derivative of that, right, 3/2 times 1/9 will give me 3/18. It's 1/6, blah, 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 done. So I have 1/9 u to the 3/2 is my integral. Oh, did I forget? No, I'm good. So now, all I gotta do is plug u back in. So I'm actually at 1/9. U is 5 plus 2x to the 3rd to the 3/2. And that's, I'm forgetting my plus c. So there is the integral of that. And if you wanted to check your work, you could do the derivative of this, and you should end up with this. Not going to do that now. Alright? Told you this gets harder. Fun stuff right here. So like I said, in your homework, they're going to tell you what u is. And you'll just have to do this process. Hopefully you wrote this down, because it takes a while. Get the u, get the du, change it. That could be a hard part you might struggle with, is changing it to where it looks right. We're going to practice with this a lot, don't worry. Do another example here. This isn't a, yeah, I'll do one more u substitution example. Let's do it again, this time with a trig function. So sine of x times e to the cosine of x dx. They're getting ugly. If I want to integrate that, we'll let u equal the cosine of x